Hello, today I am going to be continuing on with some more work on my debugger, and I think last time I said I was going to be doing something a few days afterwards, but ended up a lot of things kind of came up, and there was a lot of reading to do about what I decided to work on, which is multi-threading support. And that turns out to be a little bit awkward on Linux, so one of the problems it brings is something I've been kind of wondering about a little bit, how I was going to manage, which I don't manage that well at the moment, which is the need to do multiple actions on the process that you're debugging, all of which happen asynchronously. So what I was previously doing was I had a command queue where I would dequeue a command to run, and every time the process became available to perform a command. But that meant that the time I was queuing up the commands, I would need to know in advance which commands I wanted to run. Like if I had 3 or 4 commands I wanted to run, I wanted to perhaps a single step over an instruction, then resolve a breakpoint, then continue, for example. But that doesn't give any opportunity with a dumb queuing system to, when the process comes back, make a decision to do something different, which you might want to do, for example, if instead of a single step completing, that you had a signal or some other thing that you needed to react to. So what I want to do instead, which will also hopefully solve the problem of multiple processes, is go for, instead of just like stupid or simple actions, what I want to do is enqueue kind of more complicated state machines. So to say that I would like to start the process, I would like to continue, and these be like kind of more holistic, larger actions, more generic actions, and then within those they would have substates where it might be, if you're starting a process for debug, you'll be in the about to start state, then you'll be starting, and then you would have started, and anything happens in between, like there's a failure or something, I would know that I was in this larger state of trying to start a debug process. Which also gives a context for errors as well, which I kind of like. So I'm just going to start working on that. So I've already made a start, I've just been kind of spitballing things, and what I think I need is a new file to represent this new level of abstraction, which I'm going to call a debug action. So previously I had this debugger file, and in my testing for multi-threaded, I've added in a little bit of code here, but it felt kind of out of place, because what if you don't want to do this? It's kind of in there and it's always going to happen. And what this is it's trying to check when the first time a program that you're debugging stops, which should happen when you launch it. It wants to set some options to say, I'd like to trace to see if any new threads get created, so that I can also control those from the debugger. It doesn't seem like you can do that before the process has started. Well, I may be wrong about that. This does work though. I have tested it, but it's not the way I want it to be, which is why I have testing written here. I could conceivably pull this out somehow into a higher level, but at the same time I want to kind of do this generic action thing because it makes sense to me. So this piece of code I'm hoping I'm going to be able to put into start process action. So here's the bare bones of that. I'm going to have this idea of this debug action process, which you call in a loop. Now you could put this loop on a separate thread, or you could just run it on the frame update loop, which is what I'm going to do at the moment. And that's what I do currently for the debugger. I have this debugger update function which runs in the frame update loop. And it just goes in and checks to see whether the state of the process we're debugging has changed, and it doesn't hang, it just kind of does a quick check. And there is apparently potentially some problems with doing it this way, where we've got this W no hang option, which is what makes it come back immediately, in that it may not properly detect process exiting under certain circumstances. So it may be that I need to put this on a separate thread and do a blocking wait so that it doesn't have that problem. But hopefully, well, I'm just going to ignore that for now because this is a little bit easier, because there's also restrictions about interacting with the process. I think you have to do it from the same thread at which you start tracing. So anyway, instead of calling that debugger update, what I'm going to have the main loop do is call this debug action process event, and that's going to understand all the states and substates. Hey, this drunk Dane. How you doing? How far along am I? I don't know when you last saw the debugger, but it's I'll take these off because there's not actually got any sound going on. But it's debugging processes. It is able to do single instruction steps. It can watch for variables and separate their scopes and show you the contents of those variables, although some of that formatting is not particularly advanced. It can show you the thread stack for the current thread, but it doesn't do a great job of trying to show you frames that it doesn't have debug symbols for. It could do better about that. What else does it do? It shows you disassembly of the source code. It matches the two together. You can switch between all the available source files. And that's about it at the moment, I think. So I had a decision of a lot of different things that I could do next, from improving the UI to improving the stack traces. And what I thought was kind of one of the more important things to do was to add multi-thread support. So I had a go with that offline, and now I'm just trying to package that together in, like, it's going to drive a few infrastructure changes, and so I need to work on those infrastructure changes first. Although I did have the process able to get events and pause more than the main thread. Alright, okay, so breakpoints, that was a while ago. I think since then the watch window, the thread window, and possibly that's it. So the watch window took quite a long time, and the reason for that is to really watch a variable you need to know a lot about its location in memory, which requires you to pull out a bunch of information from the debug data, and the debug data doesn't have, like, the libraries that I was using, which is libdwarf for extracting that data, didn't seem to have functions for doing everything that you'd need to do to get that out. So I needed to write dwarf expression parser, which I'd written half of before. I've written this disassembler for those things already, but I needed to write the virtual machine that did it, and that's all working now. But that took a little while. So, as I said, I'm going to have this debug action process running every iteration around the frame loop, and it's going to need to understand every interaction I want to have with the debugger at kind of a granular scale. So I could put in some more things here, more debug actions I know that I need. So I want to be able to spawn a process. I would want to be able to do a continue on a process, which would be one of the other ones I know I need this kind of two-phase thing for, because when you do a continue, you can't just resume the process, because you might have software breakpoints that you need to do things with before you do that. So there'll probably need to be like at least a single step first. Then you need to do something with the resolving or putting back the breakpoint, and then you can carry on with a proper continue. So that's going to have a bunch of substates as well. I guess you'll also need... So it's going to be a state that you're in where you're kind of listening. I might just call that none. There's no action, but you still want to be able to listen for events to happen. Listen for breakpoints and signals. Right. This one's going to need to be able to deal properly with restarting the process when it is on a breakpoint. Captain Craft. Threads and dwarf expressions. Dwarf expressions are fun. I can give you a few hints if you're interested about how I did it. It's not to say I did it a particularly good way, but I did it a way that seems to work for now at least. There's a whole load of things that I haven't even implemented in dwarf expressions because none of my processors have needed it yet, and it's kind of unclear until you find one of those cases exactly how to deal with them. And some of them are kind of awkward as well. So one of the instructions that your dwarf expression can have is to run, I think, another dwarf expression, which is, you can imagine that just takes it from being something simple to be something much more complicated. You start having to restructure things a little bit. So in lieu of doing that, I've just kind of not implemented those things and I've never needed them yet. There's a whole load more error handling to do as well. For example, there are certain instructions that can technically appear in dwarf expressions but would be invalid under certain circumstances. For example, if you're trying to work out the frame register, like the, what's it called? Frame base? I think it's something like that. It's where the start of a frame, or where all the variables are offset from. And when you're working that out, you can't refer to some of the registers because they are kind of what you are currently working out, but other expressions will refer to them. So it's like a kind of restriction depending on what type of expression you're evaluating as to which things are allowed, and I haven't got any error handling for that. And that's the problem when you're reading in a binary file. You don't want to assume too much that it's not been corrupted or that it actually has valid stuff in it. So there needs to be some checking involved. For threads on Linux ptrace, I've seen comments in various places that it's not particularly nice. Particularly if you want to attach to an existing process that's multi-threaded, I think it's a bit of a pain. So it seems a little bit easier if you're starting the process yourself. Right, what was I? So in here I want to spawn a process. Process, wait for it to start, then set options. Aim and low, good to see you. Okay. So this is the one I'm going to work on first. So I'm just writing code like all this stuff exists, but it totally doesn't. It will later though, so it's just kind of writing usage codes, I guess. So to start the process, we're just going to call through to the existing function. Like I have this queue up function up here that says like, if you want to start a process, you call the debug action. It sets a bunch of things up. This could be a queue, but at the moment I've just added a single action into it. It's like a single next thing, so it's like a queue of one. But it could be a queue of more than one, like if you wanted to be able to click multiple buttons, like I would like you to start and then, I don't know, pause or whatever, then it would queue them up, but I'm not sure if I want to do that. Like if you click start and you click pause by accident, or Like if you click pause and then start takes a while and now you don't want to pause anymore, maybe you don't want to queue up actions, but maybe it's an option for later if it turns out to be something you might want to do. So at the moment I'm going to implement it so that if you hit a button, you can't do any other interactions with the process until that's resolved. Because you can only interact with the process usually when it's stopped. There's a few things you can do when it's not stopped, like I think you can read the memory of the process when it's not stopped, and a few other things. So I don't do line stepping at the moment. It's on my list of possible things that I could be doing next, but I decided to do multi-thread support first. I do want to, I've got a whole section of stepping that I want to do, but I want to think about it from a perspective of multi-threading, because a few things I noticed when watching like Handmade Hero streams is that Casey complained about the ability to do stepping in a way that made sense with multi-threads. So I wanted to kind of think through what I should do with all the threads when you're pausing the process or when you're single stepping. Do you want one thread to single step and the others to not single step and be frozen, or do you want them to just run on and pause naturally wherever they have to get locks or something? I'm not 100% sure what I'm going to do with it, but I want to think it through from a multi-threaded point of view, and I want it to work with multi-threading, so I'm going to leave it for a bit. But I could have done that beforehand. That was kind of arbitrary. I don't think there's that much in it in terms of efficiency of working out how something's going to work. But yeah, what I'd envisage doing for stepping a statement line would be to scan through forwards in the assembly until I find an instruction that's a branch or a call or something which doesn't carry on directly from the previous one. And if I see that the line numbers change before that point, then I would create a breakpoint there and then continue to that breakpoint, probably, depending on how annoying breakpoints are for that. I guess you could single step until that point as well. I'm not sure which is the best. If there's a branch or a call, then that's kind of more complicated because it depends where it goes and whether I know what line it's on when it gets there. Because you could call out into something you don't know anything about, and then it's unclear potentially what you want to do in that case. I guess you'd want to step over it, I'm not sure. I need to think about it. No, unfortunately I have not solved any of those problems yet, but there are a lot of problems I think to do with stepping, particularly in code where you don't have debug information. Yeah, breakpoints are kind of annoying, and one of the reasons why they're annoying, I was hoping it wasn't going to be this way, but research has suggested that it is, which is that when you set a breakpoint you modify the code, and if you're multi-threaded that means that any of the threads could be in that piece of code when you're manipulating the breakpoint, which means that to be accurate as to what things stop on that breakpoint, you need to be careful about how you set and clear that breakpoint, because you can't actually step over that breakpoint properly unless you clear it, because it obscures the real instruction, which I'm sure you're aware of if you've done any of that, which makes it a little bit of a dance as to how you get things to work accurately, especially if someone could branch directly onto that breakpoint without going through, say, the instruction beforehand. Otherwise you could do something where you set a breakpoint before, on the instruction before, and then you could clear the breakpoint, step over it, set it back again and clear the other breakpoint. But if you can branch straight onto it, then the period of time which you're clearing it so you can actually run the instruction when some other threads should perhaps be stopping on it. Well, that means now you have to stop all the other threads to be sure that you can mess around with that breakpoint, which is kind of annoying. You know, there's a lot of really annoying things with software breakpoints, it seems. Yeah, single stepping instructions kind of, that's slow, but whether it's slow enough to care from one line to the next, I'm not sure. Like if you had a single line that expanded out to a lot of assembly instructions, that would make that line slow. I guess the best thing to do would potentially be to do it both ways and choose which one you're going to use depending on the number of instructions it has in it. Also might have some kind of call to another instruction or branch. That could be annoying if you wanted to single step like through a whole function. I don't know, it just seems better to use breakpoints, so I don't know. It's almost tempting actually to use a hardware breakpoint for that, because it's such potentially short period of time and you're probably only doing one of those on a thread at a time, and the advantage of a hardware breakpoint being that you don't have to change the source code in memory, or sorry, the assembly code in memory, machine code, because you set it in a register. So that might be better. Does the debugger run at the moment? Not unless I comment a bunch of stuff that I just done out. I could make it run if you want to see it. This file I'm writing here isn't even being compiled at the moment, so all I need to do was get rid of a bunch of this stuff, I think. I was just noodling around thinking how I'd want these structures to look, so I'll just comment those out and I can probably compile it. Well, that seems to compile, so you know, it's always a good chance. I don't know what I'm actually debugging at the moment. Alright, so I'm debugging this multi-threaded program because of this testing I was doing. I didn't stream any of this, so I don't think this has been shown before. So this is just a small program which starts a thread, and the main thread and the thread you start both spin in a loop, printing something out. I think I got to the point where when this thread starts, I attach to it and it pauses. Initially when you ran this program before I made those extra test things, the main thread would be paused, being debugged, but the worker thread would spin around printing out the message. So if we launch the process, everything's done on hotkeys at the moment. I don't have UI for very much. One thing I have UI for, I think, is switching between files here. You can choose which of the source files connected to this program you're looking at. So I guess this is part of the GNU library. This is my main program. It's only a one file program. So this is running. We can look at this assembly. I think this has been there before. We can look at the watch window, which just contains the registers at the moment. And then we can look at the thread stack, which, because we haven't actually got into this code yet, it's just currently in probably _start or whatever part of the C runtime library when things start in. Miblo, I created that file picker on stream, I think completely, in the last 2 episodes. So yeah, we can hit continue, which is going to put me on this. When I start the program, I automatically create a breakpoint in main, so that you can just go straight to it. So the same stuff that was here before, you have breakpoints, you can highlight with this kind of purple thing over lines, and it on the right hand side it will take you and show you the corresponding assembly for that line. These little tabs on the left here is the line information. think the different colours are something called the discriminator, and different discriminators I think have different colours. I think that's when you have multiple statements on the same line or something. I can't exactly remember why the colours are different, why there's different things there. You can see I haven't clipped my panes properly here, because this one's overloading, overdrawing over the edge. So you can see the thread shows you're in main, and whatever C runtime or whatever function is the parent of that. Then you've got the registers on the right here in the watch pane. This white box represents a scope. So we only have, we haven't entered main yet. Oh, maybe we have. Let's see, do we have any? Yeah, okay. I was going to say I would expect to see two scopes normally when you're inside a function, because you'd have the global scope, but there aren't actually any variables declared in the global scope of this program, so that's why there's only one. So we can hit N to step an instruction, and you can see that the address here is moving along, and if you look at the right, you've got disassembly, which is called into a function, which was the pthread addr in it, and because that isn't part of our program, we don't have debug symbols for it, it's not showing any information against the frame. But if I set a breakpoint here, we can continue to that. And we're back inside main here, and hopefully, I don't know, there's not really much interesting to look in the watch pane in this program. I had a different one which did. Good evening, Mr. Toast 02. Yes, I do show the assembly for the line if the address of this instruction for this line is not contiguous, I still show it. The only thing I don't do is I don't try it. If it doesn't fit on the same screen, I only scroll the assembly pane to the first instruction for that line. So if there's another, I don't know if there are any like this, I don't know if there are any split, but if it's far enough away it might not be on screen, but you can scroll up and down and it'll show up in green any one which is associated. Mostly they're in blocks though, so you'd have to go through and see if you could find one that wasn't. What else? What else cool is there? There's not really much else cool. We can see this program running, I guess, and see it start a thread. It's not really a good place to put a breakpoint. Oops. I hit home. Okay. So now we've got two threads. They're not showing up because I haven't put the information here, but maybe it will say in the debug output somewhere that we started a thread and we spotted it. And we have a quick look through. Yeah, so if I can get the cursor to show, come on. This here, thread stop with thread ID, is the debugger noticing that the new thread in pthread create had started, and it stopped it. That's as far as I got. I mean, I only just started with the multi-threading support off stream. GCC likes to split up loops. Let's see if we can see that. This loop here. They seem to be together. Those set of lines there. I thought you meant a single line being split, which does happen, but it obviously has not happened in this loop. There isn't really a condition on this loop since it's a while one, so maybe that's why. Anyhow, that's the debugger as it stands at the moment. Oh, it's also got like these panes which you can open and close, and here you can see every time we like do something with the UI, pretty much it runs a bunch of tests, and those tests are me checking that the dwarf expression evaluator is working, and it seems it does it a lot. It's a bunch of simple tests. But yeah, I didn't want to separate them out into separate tests, so I just put them in line and I never got around to disabling them. Maybe I should do that now because it produces quite a lot of like random output. That is going to be in binary file, I think. So here I've got this function evaluate dwarf expression. Right. Yeah, I'm not sure what you would do for a line step there. I guess you'd step to the one line and you'd kind of hit step line again and it would step backwards to the previous line. I don't know. You'd still be going forwards in instructions though, right? It's just the line pointer would go boom, boom, boom. Or maybe you'd just skip over them the second time. I'm not really sure what you'd do with that. Anyway, this is the code I've got for my dwarf expression evaluator, and the cheeky bit, yeah, this is all of the dwarf stack operations. So the expression evaluator machine is a stack machine, so I have all of this stack manipulation code here. And then it's a simple kind of, you've got your instruction here which you can pull out of the expression, and you can find out what the extent of it is so you know when to stop, and it just kind of goes through executing the instructions and with a big switch statement. There's a few special ones because there's like literal codes between 0 and 31, so you can just work out what they are. So these just push a value on the stack, for example, so you know, you work out what the value you need to push is and push it on. Yeah, this sort of stuff. And then each of the other instructions is kind of a statement here. Most of them are stack pushes, but some of them do stack calculations. You see I haven't implemented some of them as well. I think the DREF ones are slightly more, like the XDREF ones are something to do with referencing parts of memory. So it turns out when you evaluate your expression, you need not just the expression and the registers, but you also need access to the memory of the process. So you end up passing in like a whole bunch of stuff. So I end up passing like my whole reference to the process that's being debugged, so that you can read out of memory. I think there's some, like here we've got bitwise AND operation on stack values, that sort of stuff. What I was going to go do here was, all my tests are kind of in, every time I evaluate the location of a variable, I do all these tests. I think what I want to do is just comment all the tests out for now. What's that, I wonder? There we go. So hopefully now I won't run all these tests every time. Although it's kind of useful, just in case I break something, I guess. But these are just doing things like when you load a instruction or a value in, make sure it's actually loaded properly, and when you perform an AND operation or whatever, make sure it actually produces the expected result. here we're putting in 1001 and 10, and we're checking that if we do the modulus operation that we get the value 1 out. Or something, I don't know. Just a bunch of tests like that. Anyway, I digress. Okay, what does chat say? Stepping isn't too bad, but user set breakpoints is the tricky part. I would decide to ignore the bug for a while. I don't know that it's a bug, I just think it's a thing that happens you have to deal with. No problems with tangents. I mean, what's the point in streaming if I don't talk to you? Well, I mean, there are times when you want to just get stuff done, but one of the reasons it's good to do streams, I think, is I find it motivating, gets me to do some work, and also it's really cool to talk to people about what they're doing, what I've been doing, how it's good or how it sucks. Usually how it sucks and needs to be improved, because that's just the stage the project's at right now. I really want to do something where I can improve on what other debuggers do, but in some small way even. But yeah, I've not managed that yet. I think you need to get to a certain baseline first. I was hoping that one of the features I added a while back, which was the ability to show you, like, if you have an enum assigned to a non-enum variable, like if it had type U32 but you were actually assigning enums into it, then to show what those enums are. And I thought that other debuggers didn't do that, but then I tested it, and actually when Visual Studio does do that. But it was quite cool. I thought it was a nice idea. I don't even know what the code for that is. Probably in this file here somewhere. Just trying to remember if that's what I did for that in the end. I don't even know anymore. Right, back on track. Yeah, keep making progress. The problem is when you reach a point where you're like, oh, there's this problem and I'm not quite sure how to solve it, or there's this huge piece of research I need to do because what I want to do is not documented well, and there's very few articles about it. Maybe I need to go and read some source code. And I try to avoid reading source code too much with other people's stuff. Anyway, if we're starting our process, then we want to check. I feel like I want to check every time what the state of the debug is here. So I want to call this debugger update every time I come in here, I think. So, debugger update. I think I just want to have the debuggy right on this debug action. And what we're returning back at the moment is the new state, I think. So that's a U32 debuggy state. I'm only going to be able to take a lot of these actions if the debug state is stopped. So I think I'm probably just going to need to say if debug ye state is debug ye state stopped, then I can decide to do a bunch of stuff. Otherwise I probably can't do any of these things, right? We're just going to sit here and do nothing. I wonder about signaled and exited though. I'm just going to put a note up here because we've not had that happen yet. Deal with signaled and exited states. So, what have we got in chat? Have you found many reading materials other than the specifications for DWARF? I haven't been able to find much that goes beyond the extremely simple parts of the debugger. It depends which component of or system or subsystem in the debugger you're talking about. If you're talking about reading the contents of the executable or libraries, then my main resource is the spec and the architecture specific specification as well, and the ABI. There's also some stuff on the, for Linux anyway, on I think it's the Linux standard base documentation, which talks about all of the debug frame information for exceptions, which is C++ support, but you need that if you're trying to debug a 64-bit process because it uses that structure instead of debug frame, which is what's described by the general debug information for DWARF spec. It might be in the ABI as well. I think it's in the ABI as well as on the Linux standard docs. If you're talking about ptrace and actual interacting with the and debugging the process, the main resource is the ptrace man page. Although there are a few articles, but again they are mainly the simple ones. There was also an article about reading memory from a process on Linux using the proc file system. That was quite useful, because ptrace offers you a way to read memory and write to memory, but it does so a word at a time, which seemed like it would be really slow if you're trying to, for example, read a large structure so you could display it in the watch windows. So I implemented reading from the file and the file system instead, and it works fine. So, and also for doing a memory view, you probably want to do it from the file. Just trying to think what other things I've looked at. Debutan did a blog post about the scope problem on his blog Transition Dreams, where he talked about the problem with having the same name for a variable in nested scopes and how many debuggers do not properly show you the right value for the right scope. I think you can get the value out, so they're usually in GDB for example, but a lot of the front ends just don't do it properly and will show you the wrong value. I can't think of anything else other than that offhand, but there probably are other resources. Oh yes, the other one is the libdwarf documentation, which is actually quite hard to come by there, but there is a version of it that I've been referring to a bunch when trying to use libdwarf, which is I think the BSD version of the documentation, even though I'm running Linux, and that's .onmand.org. So this man.org. That's the libdwarf doc that I've been looking at to try and work out how to use it, or at least the API. Other than that, I've been looking at just the standard dwarf doc here, the x86-64 API on linuxfoundation.org. What's this one? This is the Linux standard base. I couldn't quite remember the name of it. So some useful information here about the EH frame stuff. If you're using libalf, then hang on a minute, this is it, more ABI stuff. There's a libalf manual page as well, I think, on man7.org. What else do we have here? This is most of the stuff I've been looking at recently. I'm not sure whether this was that useful. This is a article about ptrace. Can't really remember what's in it. It's SDL stuff. More SDL stuff. I was trying to work out how to do something in SDL. Oh, that's the. This is the ptrace page. I look at this one quite a lot. And that's me trying to do something with the Linux version of Handmade Hero. What else do I have floating around? So I've been looking at WaitPid, which is what you use to interact with ptrace, as you probably know. There's this interesting version of the ptrace README on Ben Nordhaus's strace repo. Ben works on Node.js, but he obviously did something to do with debugging at some point. And I came across this. It's got some extra notes in here about problems and information, but it's mostly just the same text as you find in the man page. Yeah. What's this? Something about stack unwinding? I'm not sure I read through this, honestly. Oh, it seems to be broken anyway. There you go. Oh, I should definitely pull up this as well. Plug for Debiatan's blog about the scope thing I just mentioned. You see here with this program under, I don't know what this is, one of the debuggers on front-ending GTB showing the wrong values for some of these variables. And I think this one does the same in kdevelop and the same in Qt Creator showing it wrong. And here's Visual Studio showing it wrong as well. But I think here GDB is showing the correct location for the variables, but doesn't actually show you their content. But yeah, this is an interesting blog post. I made sure that my scope stuff solved that problem because I really wanted something that a bunch of debuggers did wrong to work correctly on my debugger, and it does. Small victories. Right. Yeah, so we've got our debuggy state. We know we're stopped, so if we were starting and that must have completed, what we want to do now is check, do we want to listen for children? I think what I'm going to do for now is just make it do it. And that's this bit here. So I don't need this flag anymore, because this flag child options set was just to work out whether this is the first time we'd hit a stop point in a particular process. But now we're in the state machine, and the state machine knows that it's the first time. So that's kind of one of the reasons I wanted to do it this way, is so that I wouldn't have to have a flag that says, oh, have we stopped yet? Of course, the obligatory to-do handle failure. extremely here. I'm forever writing, like, do error handling properly and stuff. This piece of arcanery also needs to go somewhere. I'm not sure where to put this stuff. This is going to be like save that there. Take the next appropriate action on the debuggy. But I think this I think actually needs to go back in. It needs to stay in here. This is like a special state thing. I think I need another state to deal with that particular type of message. So what's happening here is when WaitPid returns, either there's no change, it's just doing what it was doing before, which should be running, or it usually should be it's running the process and it hasn't stopped. But if it's not running and there's no error, then we can use these macros here to work out what happened. Now if we stopped, there's other things that could have happened. So I think I want to expand this out a little bit and say, sure, we're stopped, but if this bunch of stuff happened, a new thread. Detect a new thread being created. So that's what this mumbo jumbo is here. And I pulled this straight out of the doc. When you set a breakpoint, do you just scan for the first address in the DWARF line table associated with the source line? Yes, I do. That's exactly what I do. I don't know if there's another thing you'd want to do, but that's certainly the simplest thing. I guess what you probably should do is break on every line in there. I don't know if it ever happens, but conceivably you could have a branch to an instruction that was partway through that line, and then it wouldn't break on that line. Or something. I don't know, it seems kind of crazy thing to think about. Interesting, I've not come across that yet. I've not tried to debug that many loops yet. So, I feel like I want to have either substates for this stopped, or an extra kind of side channel of events that might have happened. Okay. Yes, seems reasonable that it might be a GCC thing to do. What might be quite interesting is to see what GDB does. Does it set a breakpoint on all of the lines, or does it try to choose a line that's, or sorry, as an instruction that's most appropriate? There's one thing I didn't show you, which is kind of cool, by the way. Might be worth doing now. Maybe this is something you can do in GDB to check. Oh, you said GDB behaves the same way. Weird. When your process is running here, you could see that even when the process wasn't running, you could see the disassembly here. But what you get when the process is running, and let's do this. If I hit tab, I am in the memory view, and if I set a breakpoint here, you can see it being set, which is kind of cool, because in this view I'm actually looking directly at the memory in the debugged process, where it has the code loaded. But in this normal view I'm looking at the file I loaded into the debugger process before I started running the executable. So this one contains all of the breakpoints I wrote to memory, which is kind of cool, I think. And this line here is like a debug thing showing me levels of nesting in scopes. There's no nesting in these though. Like if there was actually a scope inside here which contained any variables at least, then you would see it. But yeah, it's mostly debug stuff. It's kind of neat to be able to visualize that memory. I do want to do some cool things with watch windows and having the variables appear in line with the source. I want to have the option to have the disassembly appear in line as well. But that's when I get the basics working a bit better. Okay, so here I think what I want to do is, for now, I am just going to set result equal to some special value. Problem with doing this, of course, is I need to save away a piece of information, which is the actual thread ID of the process, or the thread that has been created. And I need that so that when I call ptrace, I can decide to do operations to the thread. Like get the registers for a particular thread that isn't the main thread. Or I think it's called the primordial thread, actually, which is the one you get when you start the process. So I'm going to need something better than just this enum as the result to my debugger update, I think. So what enum do we have? I guess it's called debuggy state. Oh, it's weird. I've got the wrong naming convention here. Okay. Oh, apparently this is this type is not actually used anywhere. I've just used U32. I'm not really sure why. This could just be debuggy state. If I spell it right, that should work just fine. I mean, there is a reason to sometimes not use the enum, I think. But So I think what I want here is like a struct. Debuggy. What are we going to put in it? Oh, I've got messages. Hold on a second. All sorts of messages. Right, yeah, let's do that. Okay. So I'm thinking. What's that here? Get this annoying little flashing thing. Still stop flashing. Okay. I think I want to change this to a struct debuggy update results. Something like that. And we have a debuggy state, and we can have a union of extra information like for the state new thread. I kind of want to call it stopped new thread. In my mind, I'm trying to decide between, do I just want this event separate, like thing happens to be stopped and it's stopped because of a new thread, but are those two things like independent of each other effectively? I don't think they are. I think when you stop because of a new thread, you might not stop in the place you thought you were going to stop. Like if you did a single step and that single step launched a new thread, you might not stop on the next instruction you were expecting. You might stop in the spawn or something of the new thread, and you actually be on a different process to what you thought. I'm not sure quite where it stops. I think it stops. The signal that you get back is for the parent, but it tells you where the child is, and the child should be stopped if you set your options to trace it. But if expecting that a stop would mean that you hit a breakpoint, perhaps. Yeah, I'm just going to do it this way. I don't know, so I'm going to do it this way. And I'm going to have a state for stopped new thread. And this one will be for like there'll be a bunch of different stops. I think. Because this signaled and exited, I think they are kind of similar. I think you end up stopped in signaled, but you just have a different signal to a sig trap, which is what you get when the debugger stops you. There's some stuff to be resolved. I have to see how it plays out. For now, I'm just going to do this. So it's a new thread. We want to save the thread ID, which I think is a pid_t. No, it's not signed long apparently. Thread ID. There we go. Is there anything else I want to store? Don't think so. Okay, that'll do for now. Means that this is going to have to return a debuggy update result. And instead of all this malarkey, I'm just going to clear this out and then say result dot state is this. I'm going to put a little to do here. Check this is a good way to deal with these. This stuff I think can go away. So here we're going to say debuggy state new thread, stopped new thread. And result dot thread ID is equal to our kid. Okay. Is everybody happy? This does mean that there's now a chance to report an error back as well. I'm going to leave it for now. I feel like with errors you want to know how all the different types of errors come through and how you want to present them or preserve them, and they kind of route back through to the user. Because you only want to present the user with information that's useful and actionable and describes something in reasonable terms. Okay, so now we're spawning the process. Setting the options. So once we set the options, we need to take this spawn what's the next thing that we need to do? It might be the case that then we are started and we don't need to do anything else. Yeah, I think I'm going to do that. I'm going to say debug action type is debug action none. So we have finished with our spawn process action. That should make everything else available to use. Ooh, Handmade after dark, incoming. Awesome. You have a backlog of episodes. You going somewhere? Or you just want something to be able to schedule regularly? Right, I think it's time to start wiring this new stuff in. Oh, what I should really check is... Did I have stuff that I hadn't checked in before? I should check this earlier. I did have things, but they were all to do with multi-threading, I think. Yeah, it's fine. So I can hack this up without too much trouble. Because I think what I want to do is wire this in now. So that means the debugger won't be runnable again for a bit. That's good. It's good to have a regular slot. I'm terrible at this. And having a regular length really helps as well. Which reminds me, how long have I been recording? Hour and a quarter. That's normally where I stop. But there's been a lot of interaction, so I want to get a little bit more done. And it's early in the evening for me. Well, I do feel like, just bear with me a second, I'm going to open the window, it's getting quite hot. Hopefully that will ventilate things somewhat. Okay. Next thing is to take this debug update and find out where we call it. I think I only call it in one place. Poor man's search here. Drake debugger. No, that's not a thing. STL platform Drake. That's where we need to go next. Possibly not where it should be called. But, okay, if we're debugging, where do we work out whether we're debugging? just going to create the associated structure here. I need to create this debug action thing. When am I going to do that? It needs to happen somewhere during startup here, I think. I'm tempted to move this to update and render actually. I don't see any reason why it needs to be in the main platform code. I mean, it is platform specific, but we could totally abstract that away. I think it needs to be in there. So let's go into Drake.cpp, go down to our update and prepare. I think this update and prepare gets called every loop iteration, is that correct? Maybe it's not good to couple those. Yeah, it looks like it's fine for now. Okay, so we can stick this piece inside here. Right. So if we are debugging, we want to do this. So we need to have one of these debug actions which we can create when we initialize. It's like a thing I can create fairly early on. So let's like do the initialization and then say main debug action what's that going to actually do? Oh, I haven't actually created this yet. So let's do that. I was using pretend struct here for what I wanted to have it do. So let's do that. Struct debug action. What sort of stuff did I say it had? It has a type. And then it's got some extra information, which I think is a union here. Release debug action spawn. What things did this have in it? It had an executable, I think. Oh, I've lost a character. Oops. And it had some arguments. And it had an argument count. And then it has some other stuff. A state. Could be an enum, debug, spawn, state. And I've had some states like debug, action, spawn, state. Do start, I think, was one, and debug, action, spawn, state, starting. Okay. And we have a debug action type, which is another enum. Debug action type. And we have debug action none, which is going to be our default starting thing. Then we want debug action continue as one of them. I think the spawn process was the other one, was it? Okay, I think that's all we had in there for now. Yeah, I'm sure there are more. Single step and such like that. I think that's all we support so far. Spawn, continue, next. Setting a breakpoint doesn't require an action, does it? No, it just requires you to be stopped. Maybe we should add a set breakpoint as well. I'm not sure. All that would allow you to do is, when you weren't actually stopped, you could set a breakpoint and it wouldn't happen until the process stopped. But that would make setting a breakpoint like block any other action. What you probably want to do is queue them up, like they appear in the UI but they actually take effect. Do you want to do that? No, you probably don't want to do that actually. You probably want to interrupt the process, set the breakpoint and restart it. Otherwise the process will appear but it won't take effect until you pause again. So yeah, maybe set breakpoint is a thing. But it's not something that currently works, I don't think, because we don't have the idea of interrupting yet. You could imagine, let's just have them in. I'll put a little line because these aren't things that actually work now. So, interrupt and set breakpoint. Could both be things. Could be you wanted to clear a breakpoint as well. Actually, you don't need to pause the process to do that because it's just a memory read, memory write. So in theory, I think you can write to the memory file if you have permission. I don't know if you need to be stopped for that. And yeah, I'm just going to write a note that says does setting a breakpoint clearing a breakpoint. Need debug stop. Because at the moment it does, because I use ptrace, and I think with ptrace memory commands only work when you're stopped, but I'm not 100% sure. Maybe they work as well when you're not stopped. Anyway, back to wiring this up. I need to include this debug action now up here. I think potentially if I look at SDR platform Drake, I don't need to include this here anymore. Let's see. So there's no failures in SDL, so that removal was probably correct. Yeah, I was thinking about maybe having some way of doing failable results. I'm just going to, oops, I'm going to hit some keys that do things. I'm just going to use a binary here. A boolean for now. Let's get into the compile, fail, fix loop. So debug action was not declared in the scope. Right. Okay, so we need the debuggy here. So let's look at break.h, make sure we add that in. That means in here. So we create our debug action, and then somewhere we create a debuggy. So here we want main debuggy. Pass in the debug action, and then all of the stuff we're going to pass in here, executable to debug, no arguments, that's all fine. So this returns a fail or pass. Because it doesn't actually start doing the debugging yet. Why do we not do that straight away? Could do that straight away. Could we not? Only if we're in stopped, right? Yeah, this is a bit dumb. I always do dumb stuff like this. Right, we're never going to be in stopped when we want to do the do start, because we already have to be debugging something for us to even get here. So this bit of stuff here, that probably needs to go in here. I think I did a bunch of things that I didn't need to do. Okay, so this does set up spawn debuggy. Hold on a minute. I'm going to leave the state here because I think, even though there's only one state, I think there may be another state coming. So we set the options. Probably want where did I find this error, right? It was like debug action debuggy. Inside the debugger update, so that means that here when we create this debuggy we need to actually store it here straight on debug action. And Drake.h debug action needs to have a debuggy, and it does. It looks like this. There's no pointer. Is that what we want? Is that what we want? What's in debuggy? Process ID, state changed, command queue. Really, it's just the process ID that we care about. Okay, I'm not happy with how this is going. This isn't going well for me. I think I want to pass in this. I'll say stick the result in here. Maybe I don't. Maybe I just want to store this off of debug action. That seems fine. Let's store it in debug action. Problem is, everyone that uses main debuggy here now needs to do main debug action debuggy, which is a pain. But anyway, we'll set it like this. Spawn process of debug. We set ourselves to be starting. We need to set debug action type to spawn process, okay. This goes down here. We don't actually want to do start because we've got rid of that. Don't need any of this stuff. In fact, that seems fine. That's just simplified all that stuff I thought I'd need. It's always the way. Over-engineering things. So we don't need that, we don't need that, we don't need that, we don't need that. We just need this. Let's get rid of that stuff. There we go. Don't need that. And still, may not even need this. I'm tempted to get rid of it actually. I said I was going to keep it because I think I need another state, but why have all this stuff hanging around now? We can always add it again. It's like this sunk cost fallacy I've got going on here. If I wrote the code, if I delete it and have to write it again, you know, cost me time. I have an attachment to that piece of code I don't need. Should not have that. So here I just need executable, arguments, argument count. Everything just becomes much simpler. Okay. Is there anything left in here to do with spawn? Spawn state. Decided to get rid of that. Debug action's got to have a debuggy though. There we go. Brilliant. So that means this needs to go below here. And then, I think, for safety's sake, I'm going to get rid of this one here and just make the other one the de facto standard thing. Okay. All that stuff can go. And that was this. Okay. What's next? What's next? I really want to get this just starting a process. That's my goal. How long have I got? I mean, it's a 2-hour stream, it's not 20 minutes. I think this needs to be an ampersand in here. I think there's so many places I've dereferenced debuggy that this is going to be kind of painful. Okay, what's next? Can I convert? This is a debug. Bug. Update. Result. Okay. Just running through those changes. Next. Child. This needs to be the debuggy, so that's debug action, debuggy. Oh, too many double characters and letters. This is the process ID, right? This feels like it should be a call into like debugger, trace new threads or something. Making that transformation here. Just that's child. That's probably why it's child in the first place. I think what I also want to do here is like I would like to also exit child on exit. I don't know. Yeah, it's not a great name. But that's what this is going to do. It's going to set the exit call flag separately here. Maybe I should do these in one call, I don't know. But debugger exit child on exit. Then we're done. See you, Captain Croft. So that should put us in the state that we were in before. I think a bunch of the stuff here has got to change as well. So let's just have a quick look through here for all of the instances of main debuggy and change them for main debug action debuggy. go. Oh yes, of course, this is not a declaration, so... Maybe I just want to do this. Void value not ignored as it ought to be. Right, so all of this stuff we've got going on here now needs to be moved inside of debug action, I think. Let's just get rid of it all for now. Oh yes, of course. Don't actually want to care about it, what it returns. Okay, so that compiles amazingly. But what we want to also do is we want to check when we hit enter. We said debugging is true. And we've got debug action spawn process for debug here, so that's good. This, interesting. I didn't even check. This is a thing that we need to do when we finish spawning this process. We need to trace, we need to exit on child, we set these options. But we also need to do this resolve all breakpoints. Now, I think what I'm doing here with debug action is I'm also, as well as encapsulating all the thread stuff that needs to happen, I'm extracting out of my main Drake.cpp where everything's kind of shoved at the moment. It's just naturally falling out. All of the stuff to do with the breakpoint layer that sits on top of the debugger layer is kind of being pulled into this debug action, which is nice because it didn't feel right sitting it in there, but I knew that that's where I wanted it to be until I found a place for it. So that's good. So I can just do debug action. I kind of don't want to call it debug action because it's not something you'll call from outside. Maybe we'll just make it static. There we go. Oh, that's what it's static. That's what internal is. Obviously not in Casey mode. I kind of want to make it private, but okay. I just put like an underscore after it, that seems reasonable for now. Just to remind myself. Maybe it should be externally facing, I don't know. But this can be like a placeholder for now. Does it compile? So I actually want this line push debugger command. This is not a thing anymore, so let's find that. Yeah, it can go. No debugger commands, they can go. These command types can go. I think these debug commands can go as well. That should break some stuff. Okay, debug command. Yeah, we don't need that anymore. For that. You can keep the other things, I don't think they do anything, but so yeah, this is the command I wanted to not work anymore. That's fine, it's been moved, so we still got it. It's just a to-do. Now we've got another one here. I'm going to skip caring about this for a minute, I think. So I'll stick a little to do up here. Reinstate this. How are we doing? Oh, 5 more minutes. I don't think we're going to get this working in 5 minutes. Too many errors to care about. Okay. Continue. We can also do the business of continue. That compiled, apparently. Okay, that's good. Surely there's more to do here. I'm just going to run this. I'm sure it must crash. So let's run it in GDB. Okay, a lot of that worked. Or did not. Completely crazily fail. So bits that I would expect to fail. Let's see. When I hit enter here, what's it going to do? Okay, so it spawned a process. That's a good start. And the process has come back as being stopped. But I'm guessing that. Can I set a breakpoint? This first thing. Okay, it thinks I can set a breakpoint. Can I hit continue? Won't work. Next won't work, so commented them both out. Thread view. It doesn't think we're debugging. It's not good. Oh, but hang on. No, that's not debugging. Oh, it thinks we're debugging enough to show us the memory view, but is the memory view really showing us? I don't think it's really. If it is showing us memory, the breakpoints have not been written here. Look, this breakpoint does not have an int3 on it. So, yeah, I mean, this is not as broken as I thought it would be, honestly. That's not too bad. It's not crashing, just a bunch of stuff that we've commented out doesn't work. This might be a good place to stop, but I think one thing I want to do is I want to copy in this resolve all breakpoints and see if we can get that working. I'm pretty sure, yeah, there's just a function for doing this here. So I'm going to naively copy this code in. It's not going to work because we need main for this. The only place we're calling this at the moment, I think, let me just check over here, resolve all breakpoints. It's being called from our debug action stuff. All this code here is a reaction to the debugger stopping, which is all stuff I want to move into debug action. So that's being called from debug action. That one is... Okay, so it's only being called here. And that push debug thing has gone, so the only thing that causes this piece of code to be run has also been deleted. So I think this doesn't need to be here anymore, because debug action process only gets called if we're debugging. Is that true? Yes, that's true. And we already have the debug action here, so we can just call this direct. So our state is stopped. This state's probably going to go away, but for now it's there. In fact, we know our state is stopped because we only call this when we know we can. So this can kind of go away. I'm going to get rid of it. We'll have to put it back in again if we ever call this from somewhere else. So we can just go through the breakpoints now. That's interesting. How are we going to get a list of breakpoints? I think their list of breakpoints is going to be moved into debug action. It's currently owned by the disassembly pane, which is kind of weird. That it be owned by a piece of UI rather than this debug action layer. I think the debug action layer needs to own this. But for now, I wonder if we can just cheat to get this working and store the main pointer inside debug action. Because I just want to see it working. So let's do that. This is super cheaty. Oh, I'm not sure we can do this actually. Main memory, is it? Main memory. In fact, what do we need out of the main memory? We need this assembly pane, so we could do okay, so I've got like a couple of minutes just to check that this works. What I'm going to do is where I create this, which is in direct.cpp. I'm going to do main debug action with this assembly thing, like this. Keep deleting things by accident. Debug, remove this. I keep saying remote as well. Ah, I think I'm getting tired. Right, let's go to a point where we've actually set that to a value. Okay, just here. So now we can cheat and do this by saying debug action. Right, oh, now we've got to do resolve breakpoint if necessary. I don't think we have this function. There was an easier way, I could have done this before, but okay. I could have just called this directly, but is this going to work? Pane does not name the type. Feels like too much of a debug hack just to try and see that this is working. I really want to see it writing something to memory. How many of these errors do we have? Not many. Okay. Let's just make this stuff work. We are debugging. State stops, it's fine. This bit, we just do that. That was a lot easier. Okay, let's just call that then instead. Do we need main anymore? I don't think we do. We just need debug action. How we doing? Oh, overrunning. Does it work? Does it blend? So I want to start this up, run it. There we go. That's what I wanted to see. So that resolve all breakpoints is looking through the list of breakpoints, which should include the one we automatically add. Yeah, main. Yes, yeah, I think so. I don't think I removed that code. So we add a breakpoint in the breakpoint list, which says put a breakpoint at the symbol main. It resolves that symbol and works out what address it's at. And the resolve all breakpoints go through a breakpoint list and it writes in the breakpoints. And so you can see that now there's an int3 inside main, which is what I wanted to check, because that shows that we're able to actually access the process properly. And we'll be able to move on to converting more of those things, extracting out all of the breakpoint stuff from direct.cpp and the disassembly pane, which is a weird place to put it. It was convenient, but it's a weird place to put it, into the actual kind of high-level debugger layer. So now we've got the low-level debugger API where you can do things like you can talk in terms of process IDs, and that's all kind of platform specific. Maybe the higher level one is also platform specific at the moment, but it's doing things like abstracting breakpoints rather than talking in terms of writing int3s into memory. And that feels good because it also then encapsulates actions like I would like to start a process, I'd like to set a breakpoint into the individual operations that need to happen at the low-level debugging layer. And that kind of two-layer approach seems good to me. Yeah, so I'll continue on with that next time. I'm not sure when that's going to be. Hopefully it's tomorrow. Thank you for everyone who stuck around to watch, and anyone who's watching on video. And I'll see you again soon. Keep having fun programming.